Hello and welcome back to the Home Lab, and today I've got a second video for you and one I've been looking forward to making for a very long time. What we're going to do is we're going to build a project from this 1960s Philips Electrical Engineer EE08 kit. So you might remember a while back I published a video sort of unboxing this wonderful old kit from the 1960s to show you what was inside and some of the projects that you could build. And I was truly amazed by how many of you remembered it and left some absolutely fantastic comments. Particularly those of you who said, well, this is how I started as a young child. I got given this, nearly everyone seemed to get it for Christmas because it was quite an expensive kit. And after blowing up a few transistors, I built some of the circuits in it and I became an electronics or radio or whatever, some kind of communications engineer or something similar. So it clearly had a huge effect on children all over the world because it seemed to be sold from Australia through the UK and out to America, etc. But at the end of that video, I said, let's have a little question in the comments. What project from this kit, so this is the EE8, not the EE20, which had more transistors and you could do more with it, what would you like me to build? Well, I got lots and lots of suggestions and they were all wonderful. And I hope I'm not going to upset anyone today because I've got to start somewhere. But what I thought we'd do today is build the 2-transistor radio set. Now, I know there's not a lot of AM radio around at the moment, but we'll give it a go. We'll see if those pesky AF transistors still work, and we'll see if we can get ourselves a working radio. So come and join me at the workbench and we'll start to do some building. It might take me more than one session, but let's see if we can get it to work and I take you all the way back to your youth back in the 1960s. But just before we start, I want to say a huge thank you to all of you for supporting my channel. It's always a great pleasure to log on and see the wonderful comments that you've left and the fact that you've enjoyed the content I've been making. I also want to say an absolutely massive thank you to PCBWay for supporting my work as ever and giving me encouragement to make more videos for you. Now, we all remember our early days of doing electronics with these sort of kits and little springs we had to put the components under. And then when we got a bit older, you might remember making those copper circuit boards and sticking them in those horrible etching fluids. Well, as you know, PCBWay make bespoke circuit boards. So if you're beginning your career in electronics or you're an old hand, why not go and have a look at their website and see the ways that they might be able to help you with your project. So let me take you back to Christmas Day when you were a young teenager or perhaps even younger than that, and you've just opened your presents and everyone else is opening presents around you, but you're taking absolutely no interest in them at all because this is sitting in front of you, the present that you've always wanted. So let's open up and we'll get out the bits that we need. So we're going to need the instruction book, we're going to need some of these component overlays, and we're going to need the feet and the board that we're going to build our circuit on. So here's the instruction book and we're going to build the 2-transistor radio. So if you remember, it's general assembly instructions, circuit construction and then general theory on how the circuits work. So here we go. Here's the layout, the card and the batteries for the 1-transistor radio, and then as we turn through it explains how to make the antenna, and later on C2 how we can make a 2-transistor radio. Just for interest's sake, and you might remember this from the last video, you'll notice the batteries were covered up and we talked about this and suggested that there was a logo they didn't want to show. But in fact, a little bit more looking into this seems to point to the fact that they'd actually put the batteries in the wrong way round, which makes it appear that the circuits as photographed here and not actual working builds. They were sort of builds and then photographed. And as with PNP and NPN transistors, you can sometimes have the top rail as positive and sometimes as negative. And I think they had the batteries always with the positive at the top. So it was all very confusing and they had to cover it up. I just feel sorry for a number of children who may have had early prints of this and never got their circuit to work, because you do need to look at the circuit diagrams in this to work out which way round to put your batteries. So let's get started. So the first thing we've got to do is take this board and select the 4 feet which are here. I've loved this sort of layout in the box. I think it's absolutely wonderful with all the components there, and it's just encouraging you to want to dive in and make something. So the feet go into the 4 corners of the board. Sorry about the light today. It's very, very sunny outside, which makes a bit of a change. And here we go, but I'll get it on the board in a second, so you will be able to see what's going on. And here's the last one. So we've got the 4 feet on the board now, so we can move the component box and start to build our circuit. So these are the 2 cards we're going to need. So that's C2, which is the 2 transistor radio, and this is the one for the on-off switch and the tuning and sort of volume bits. So the next thing we need to do is get the components onto this card, which is the potentiometer, the variable capacitor, and the on-off switch. So the 3 components we need, interestingly, I seem to be missing the switch in my kit. It seems to be the only bit that's missing. So we've got the potentiometer, we've got the variable capacitor, and then in here is the sort of nuts and bolts that hold them onto the board. So we'll pop in the potentiometer, and there's a little slot here for the key there. So in it goes, and then this goes over the top. Doesn't leave an awful lot of thread, but we've got the big washer there. And let's see if we can get that nut on. Feels like an aluminium nut, I think. So just enough threads to do that. We'll come to the switch in a minute, and then we've got the tuning capacitor. So we'll push that underneath as well. And then what happens here is we have these split pins, and we put a grommet on the split pin. There's still quite a bit of rubber left on that, so it's lasted really well. There's one. Here's the other one. And feed the tuning capacitor up through the card. Do you remember doing this? It was probably very fiddly back in the day. And we'll put the split pins through, and then we bend over the legs on the split pins, and that will hold the variable capacitor in place. So there we go, that's those 2 mounted, and the first mistake I made sorted. I put the split pins through first and put the grommets on the back, so that holds it nicely. So the next thing we've got to do is select these lovely chicken head knobs that are in here. My finger's bigger than small children, probably, so fiddly things, but get them out. And we'll get those mounted up. Fiddly bit coming up, because obviously you've got to tighten these chicken head knobs actually onto the shafts, and they give you a nut for that, which drops in here, and then a screw that goes into it, and I can see that's going to take me a while to get lined up properly, but we'll get there in a minute. So we've got the screw and nut in this knob, and we'll turn this all the way anti-clockwise, line it up with the scale. It's actually pretty tight already, and then just tighten it up so it's on properly. So that's that done, and as I said, the switch is missing, so I'll deal with that later. And let's go back to the manual quickly, just for a quick read. And it says, we advise you begin with the first model in the group that happens to be the most interesting to you at the time. And pick that diagram, A1, B1 or C1. Well, in true boy form, we're going to ignore the instructions and go straight to C2, which is the 2 transistor radio. And we're going to lie that card on top, and we're going to make sure that the holes all align. so we might have to jiggle this card around a bit so we've got the holes aligned on both boards. Now, I'm obviously not going to go through every single little bit, but I wanted to show you the sort of fiddly bits, the annoying bits that you had to do before you get started. Because, of course, once we've got this card on and the springs in place, the fun begins because we can start building with the other electrical components. Now, I'm sure you all remember this fiddly bit. Whole series of springs that go on top, and I hope these are not too corroded and rusty, and then hairpins that push up from underneath. So again, there's a little bit of preparation to do before we get the components out, but it's worthwhile getting this bit right. So let's see how I get on with this fiddly bit. So get the spring out of the way, and I've got to poke the hairpin up through the hole from beneath the board. It's these bits that take ages, isn't it? And you just want to get the components out and start building. And then squeeze the hairpin together and click. There's our first spring in, and I haven't counted them, but we've got quite a few more to do, so I'll get on and do that now. So as with all these things, springs beginning to go in, the more you do it, the better you get at it. And you notice I've also put some little grommets here on the feet because the feet kept falling off. But I found a technique with these which is quite useful, is not to push the hairpin all the way through like that, but to have it back a little bit, which keeps it crushed. And then you can just push the spring on from above and click. There's the spring. So it's a much easier way to do it. Oh, as an aside, and I wasn't sure I should mention this because I'm not sure if I'm going to say it correctly, but when I selected one of the springs earlier, I noticed that it had got a really long brown hair trapped in it. So who knows, this kit could have been owned by a girl at the time or a brother and sister making it together. Who knows, but it's a nice thought and a bit of history that's lost in time. Well, that's it. Pretty sore fingers, but that's all the springs in, or at least most of them in, because I seem to be missing a couple of hairpins for 2 points that I've left here, because we can easily wire into other points, so we don't need those. But I think what I'll do later on is actually manufacture some pins. So we're not completely through Christmas Day yet. We've got our board with all the springs on it. That took me about half an hour. So now we can start the fun bit, which is getting the components put into the right places on the board. So where shall we start? Well, let's start off with C17, which is a 0.1 microfarad capacitor. So we've got all our capacitors here, and that's the one we need. It's got a rating of, is it 160 volts? So that should be fine for what we're doing. And I remember people saying with the transistors that all this bending to get them to fit under the springs caused the legs to break off the transistors, which was a bit of a shame. And it was a very expensive repair to buy new ones. But we'll see if we can do it without damaging any of our components. So that's that one in. I've got a feeling that none of this is going to work to begin with because it's all so rusty, and I also haven't tested any of the components. But I think what might be more fun is to actually build it first and then do some fault finding. It's a brave approach, I know, but let's do that anyway. So I won't build it all in front of you, but here's the next capacitor. It's the same value and that fantastic voltage rating of 160 volts. So I guess it made them very reliable, but also you could take them out, struggling here, you could take them out and use them for another build that you wanted to do later on. Maybe you're going to build something with valves or what have you. So there we go, that's that one in. Maybe we should look at some resistors next. Well, do you notice what I've only just noticed? I thought this card hadn't been in any way damaged at all, only by me pushing the hairpins through. And, yep, there's not a spring here. And that's the original chad, do we call it? The bit that should have been punched out. And there should be a spring there, so going to have to sort that one out, aren't I? So now we've sorted out this spring here. I've stolen it from the battery negative point. Let's fit that resistor here, R7. So if you remember, the resistors came in a little pack like this, but they were unlabeled. and so you had to know your resistor color code. So we need 3,300 ohms. So I'll select that one first. Here we go. Off it comes. And the wires on these are a little bit corroded too. And so what have we got here? We've got orange, orange, red. So orange 3, red 2, so 10 to the 2, or 2 zeros, so 3300. And that's our chap there, the 3,300 ohms. So I'll pop one end of that under the spring. There it is. And it's fallen out straight away. So this must be something you were all used to. Let's try again. That under there. It's really very fiddly, this, but in fairness, I'm doing it with the camera in my way as well. So there I go, blaming my tools. So not a very tight connection, but we'll sort those out later on. And now for yet another bit that might let us down in the build, but let's go for it anyway. Let's go for one of the electrolytic capacitors. So we're going to go for this one, the 4 microfarad electrolytic capacitors. So we've got the crimp on the can here, so that's the positive side. So this is the bit I'm holding is the negative end of the capacitor, and that seems to make sense because with these circuits we've got the negative rail at the top, so it's going to go in that way around. So we'll click under that spring. Sometimes it's easy just to poke the wire all the way through. Still not holding it very well. I can see we're going to have all sorts of problems with contacts here, and the same with that spring. So there we go, that's the electrolytic in, and I wonder if they're still working. The next capacitor I wanted to put in was this one, which is 47,000 picofarads. So they're obviously trying to get young people who are building these kits to play with different units of capacitance, which is interesting. And I've got the capacitor here, but what I'm going to do is bring it up close to the camera and show you what it's marked, because it's just a little bit confusing if you don't know about this sort of thing. So if I can hold my hand steady, I don't know if you can see the marking on this capacitor, but I think it's 47 with a comma and 3 zeros after it, and then after that's the picofarads. Now, I think you all know what that means, but and I've got to be careful what I say to students from overseas and those of you who are from overseas, but it's really confusing, this, because is it a comma or is it a decimal point? And I think firstly we shouldn't be using those symbols when we're printing, but secondly, if you're abroad and that's a comma, so Holland, where this kit came from, if it's a comma, that's actually a decimal point for people from there. I find this extremely confusing. Those of you who speak German will know, you say comma when you say 3 euros, comma 57 cents or something. But it's a decimal point. And if you look on a pocket calculator, it's a decimal point. So I get a bit stressed out about this when teaching students in the UK. That they really should be very careful with that kind of notation. And when you get very large numbers from abroad, you can get lots of decimal points in them and then a comma at the end for the hundreds. I haven't explained that very well, but if you know what I'm talking about, that I hope isn't a decimal point, but it's a comma to separate the zeros. Anyway, let's stick it in the circuit and I'll stop ranting. So, rant over, trying to decide whether points are decimal points or separators to make numbers easier to read. All very confusing, or at least to me anyway. So there we go. I think that's in. No, it's not. Could have guessed that, so let's have another go. So I bet some of you have been shouting at me when I've been putting these components in, and we'll talk about that in a second, and I find this quite amusing. And there I was having a rant about, is it a decimal point or is it a separator? And I've got no right to do that, of course, because I've put all these components in incorrectly. Because the clever thing about the design of these kits was that the springs actually weren't the bit that sort of grabbed hold of the component like they did on all those other kits you might have played with. In fact, it's far better than that. You push down on the spring, thread the component like this, and then you've got this problem of bending a wire, so you need to bend the wires in advance, and then thread that through, and then the spring pushes back up and grips the components. So, in my true schoolboy error way, I'll get all the other ones out, put them in correctly, and we can carry on. Right, that's sorted that error out. It was a bit stupid of me, really, because one of the things about these Philips kits that made them so successful. And there were lots of reasons why they were so successful, but one of them was this clipping system was so much better than the normal springs that you saw on the other electrical kits. So there we go. There's an interesting value. 125 microfarad electrolytic capacitor in the right way round. And I bet you that's, well, when I say it's not working, some of these old capacitors actually still work quite well. But we'll see what happens a little bit later on when we test the radio. So plenty of other components to go in, but the bit we've all been waiting for. Shall we get some germanium into this circuit? So let's do the diode. And if you remember, the diode they used here, the EE08, is a lovely big glass diode. In fact, I'll be doing a video on that at some stage and showing you what the construction looks like inside. It looks as good as it was the day it was manufactured. So we've got to be careful to get it the right way round. And I feel really sorry, but I've got to actually bend the legs to put it in, or the leads. So that's that one. I wonder if someone bought a new one and because they blew the previous diode and then never used the kit. So it's got to share that space there. Not gone in. Fiddly fiddly. I'm sure you all remember this process. And then it's got to go under here as well. And I'll see if I can turn that one a bit. You can actually turn the hairpins underneath to get them to point in the direction that you want. And there we go. I'll tidy that up in a minute. But we've now got some germanium in the circuit. Right, it's transistor time. So let's select transistor. And I know I'm picking the transistor here, the AF116. Now, I know these are an absolute nightmare for tin whiskers, and you might have seen my tin whiskers video. I really don't want to rip this package, see if I can get in the other end. So it probably won't work, but let's build the circuit anyway, as I've said. So out it comes. And I pointed out earlier on that all the legs are twisted together, and someone said to me that might have been on purpose, so it would avoid any electrostatic discharge damaging it. I'm not sure at all. The other thing with these is, do you remember that wiggling them into these clips often broke off the legs on the transistor? And I've only got one here, but I've got a tiny little red cup here, and I think they referred to this as a glove, and you could actually slide the transistor legs through it, and so they didn't bend right at the top and break off, which was a later addition to these kits. So let's see if we can get this germanium transistor, this AF116, into the circuit here. So here's our AF116 germanium PNP transistor, and it says Mullard, Great Britain on it. Interesting enough, it doesn't have the transistor designation on the side, but it has it on the top in a rather sort of gold print, and it's very, very difficult to see. Now, if you remember, these transistors often, or at least transistors like them, often had a little red dot next to the collector, but this one doesn't. So you need to know the pin spacings are really close for the emitter, base and screen, and then the collector is further off to one side. So they're asking us to wire up the emitter and the third lead, which is the screen, together, and then the base and collector separately. So what I'll do now is try and wiggle this in on these spring connectors. Well, that was easier said than done, but it's actually in. The leads are almost not long enough. I'm just checking to see if they're not touching. I don't think they are, but we can fiddle with that a bit later on. And it's going to get trickier and trickier in a minute when we've got this spaghetti junction here, or should we call it Piccadilly Circus of components, where we've got 1, 2, 3, 4, 5 having to join on this one spring. So let me now get on and put a few more components onto the board. So this rather corroded AC126 that came out of this box does have the little red dot on it marking the collector, so we can separate the leads very gently. There we go, this one definitely looks like it's been used, and if we separate them like that, we've got the emitter, the base, and then the collector. So let's get those wired in here, and it's getting a bit busy under that spring, so I hope we have some success. So I managed to get it in there, and whilst these kits are absolutely fabulous, I think that's one of the weak points, the number of components that have to go onto one spring, and the fact that the legs on these transistors are only just long enough. I mean, I think I could bend it a bit more and get them to fit, but it would have been nice if they just bunched that up a little bit more, because the resistors and capacitors are cheap to replace and they've got very long leads anyway. But I didn't design it, and I wouldn't have done such a good job, so perhaps I should shut up. Right, here we go with another capacitor with its 160 volt rating here, and this is a 0.1 microfarad capacitor that goes in here. So it's kind of knowing where to start, really. I can see why there are so many sort of kinks in these leads, because I think the previous owner sort of put it under like that and then desperately tried to get the other end under the spring by sort of putting numerous 90-degree bends in it. So let's give that a go. I think that's through. I've no idea what the connections are like. I might swap it to this side to make it look a little bit better. But anyway, I'm missing a capacitor here, which I'll need to replace. We're missing the switch and a couple of springs, which I can do something about. Now I've been looking at the clock now. I've been doing this, obviously with stopping and starting the camera now, for the best part of a couple of hours. So that's gone quite well. But to be honest with you, I feel like I need a bit of a break now. So is this how it went for you when you built your kit, if you had one when you were younger? Did you do a couple of hours, maybe 3 hours, and then have a bit of a break because you were quite tired like I am, and need to have a bit of lunch, I think? Or did you just press on, really excited, not waiting at all for your radio to be made, and with the family shouting at you, "Come on over here, Aunt Mabel's arrived and she wants to talk to you," and all you wanted to do on Christmas Day was ignore everyone else and get on and build your Philips EE08 radio circuit? After saying it was a beautiful sunny day earlier, having had lunch and wanting some fresh air, I thought it might be a good time to go and string up an antenna in anticipation of a working radio. Well, the weather had other plans though. I needed to extend one lead of this replacement capacitor for the one that was missing. So here's a nice hack for you. Don't throw out those laser printer toner packing ends. They make great small screw and compartment holders, but they also work as a spare pair of hands if you want to do a bit of soldering. You can even put the tip cleaner inside it to keep it steady, or you could put your solder reel in there instead. So I'm back from a well-earned rest, and you'll see that I've replaced this missing capacitor with a Plessey one. I hope Philips don't mind me using one from a competitor. It's a slightly different value, but it should do because it looks old and it's looks as if it's from the time. I think it's out of an old Roberts radio, so that should do the trick. I've also moved a few of the spring clips around until I make a few more of the hair clips that go underneath. Some of them double up, so it doesn't really matter. I mean, this one here for the battery we don't really need, as we've got a connection here. We've also got a few wire links to put in, and they're easy to miss and forget, so we'll do those in a minute. And we've got to connect these two up and the switch, and of course the all-important part, getting the antenna bar sorted. There's a little trick you might remember in the box, that underneath the semiconductors here, hiding underneath them, are little bits of wire that will enable you to finish the wiring on the project. Well, the good news is I've managed to claim a few springs back, so I think we're going to have enough. And there I was thinking there weren't enough in the kit. But of course, these holes remain as they are because the wires have to come up from the variable capacitor and the potentiometer through from the underneath the board. So we leave those blank, of course. So I've removed those springs from there, which is brilliant. And of course, if I'd done the right thing and actually looked at the diagram first, I'll just zoom in on this a little bit, it's perfectly clear that there are wires coming up through these holes. So serves me right for not doing that in the first place. And I also happened to read that I'm the poorer kid and only got the EE08 for Christmas and not the EE20, because the EE20 had a slide switch, but we're going to use this one here. So what I've got to do now is do a bit more wiring up from underneath the board and through using this red wire that was supplied. So just to show you or remind you how these were wired up, and I think it's a little bit annoying that should have done this really right at the beginning, but we're doing it now anyway, because we've got to turn the board over with all its components on. I suppose if they don't fall off, that's a good sign. And then back to the clever Phillips technique, you take one of your springs, push it onto the component like that. There we go. And pass your bit of stripped wire through, and hopefully it'll hold, and then this is the bit you're going to pass through the board. The underboard wiring is a little bit tricky, but the variable capacitor I've got in using the normal springs, but the potentiometer has even shorter lugs on it. So for that, you have to use the short springs that are supplied in the pack. And they're really fiddly, and I bet plenty of these went flying across the room on Christmas Day, never to be found again. So that's the underboard wiring done. Took a while and quite fiddly, but we've sorted it. And if I turn it over, you can see now that all that's really left to do is the antenna coil and the crystal earpiece. But there's one problem that I've come across, that you're meant to be able to strap this piece of ferrite rod down, and there aren't any holes in the card, and there should be because there are holes in the board. So I took out the one transistor circuit, and interestingly enough, you can see someone did actually build this and made their own holes there so they could hold down the ferrite core of the antenna. So now to the assembly of the ferroreceptor. Now I should have done this right at the start if I was following the instructions properly, and of course I'm not following them properly, as is typical of me. But actually I think it's quite a heavy component, and it would have got in the way of the build, especially when we turn the board over. So I'm going to put it on now right at the end. So I better read the instructions. Assembly of the ferroreceptor. Slide the aerial coil onto the ferrox cube rod until it's precisely in the middle of the rod. Push a sharpened matchstick between the coil and the rod so that the coil cannot change position. Then push on the two large grommets as shown in the illustration. Now your ferroreceptor is ready, and you can mount it on the wiring diagram. Place it so it lies roughly on the illustration on the card, and it's turned so the tag with the red wire lies closest to the card. Okay. If required, remove the grommets. Then mount the aerial with the aid of small bits of string, never wire, running across each grommet and through the holes, and knot them below the board. So those are the holes we haven't got, but this is the bit I like. The sort of knot you must use, of course, can be chosen by yourself, as you'll later want to remove the aerial, and perhaps best if you tie the strings the way you do up your shoelaces. Okay, so I think we better get on and fix the antenna. So, sharpened matches and the like done. Let's see if I can remember how to tie my shoelaces. So, string goes in here. Everything's very fiddly, but I guess whilst younger children might not be quite so dexterous, they've got smaller fingers. So, even this is a bit fiddly. Let's see if we can get a knot in there to hold it. Oh, I think that might work. Chance of getting a loop through there, who knows. I've perhaps made the string a little bit short. So you'll notice I've gone for reef knots top and bottom because that bow up here was absolutely hopeless. And in fact, the bits on the bow, we're going to get caught up in the turns that we're going to put here on the antenna. So that's all sorted. You'll also notice we're missing the yellow wire that's been missing from here for a very long time, I think. So I need to solder one of those on, and then we can get our ferroreceptor wired up to the rest of our radio circuit. So with the ferroreceptor repaired, it's time to connect the last lead, this grey one under here, that goes to the cathode of the OA79 diode. There we go. And that's that all connected in. I haven't found that particularly easy because I need to double check which coils were which to get them the right way around, and I made myself a little table here. I'm not sure that's actually in the instruction book, but there is a colour picture of it, so I managed to work it out in the end. It's another case, I haven't actually mentioned any so far, where a child building this I think might struggle a bit without any prior experience. Whereas people like ourselves who've done a bit of electronics sort of know which way things are going to go and know what to check. Anyway, that's all done. So all that's left to do is to connect up the crystal earpiece for the batteries to be connected and some form of external antenna to give us a bit of a stronger signal. Thankfully, a couple of days later, the weather improved, so I could get outside and quite literally string up an antenna between the corner of the pergola and a hanging basket bracket that was on the house. I had a reel of multi-stranded, quite thick copper cable that's used by electricians for wiring main supplies. So I thought that'd do the trick. And with one end on the pergola, the other end coming down from the bracket on the house was really close to the outdoor tap. So that would be close to a point that I could use for the earth point of the radio. I was lucky to have a little bit of quiet time during the evening, so I thought what I might do is just get the multimeter out and test some of the connections for continuity. And would you believe it, I didn't find a single fault. So the radio looks really good, but the only thing I haven't done is test those transistors yet. So, seeing as we're going to use an external antenna that we've wired up outside in the garden, I've got to get the signal from that antenna into the radio somehow. So it was a bit of a fiddly job, but I've spent a bit of time winding about 3 turns, or maybe it's 4 turns, around the top of the ferrite bar on the ferroceptor and into the radio itself. I've also added a green wire here, and that's the earth, and that's going to connect externally to the garden tap. So we've basically got a radio, but it's still not going to work because we need to provide some power to it. So to power the radio, I thought we'd go traditional and not use a PP3 or a bench power supply, but actually we'll use the recommended power, which is these wonderfully named 4.5 volt flat batteries. The manual explains how to put the batteries in on the board, and you've got to put them next to each other and then pass an elastic band over the top of them, and then underneath pin that elastic band down with some little bits of wire that you've bent to make sort of holding brackets. Once that's done, because these are 4.5 volts and we need 9 volts, we've got to wire them in series. So you take a remaining spring and hairpin and join together the two sort of facing terminals of the two batteries, and that wires them in series, so we're going to get the 9 volts that we need to power the radio. I can see this being a bit of a fiddly process, but the main thing to do is to make sure that we get the batteries the right way round. Because if you remember on the photographs of the circuits, the batteries were covered up, and that's because they photographed them the wrong way round. So with these type of transistors, you remember the practice of the day was to put the negative rail at the top and the positive at the bottom. And I think the batteries were originally photographed with a plus at the top, which is why quite a few people, I think, failed to get their circuits working. Anyway, there's an elastic band in, so what we're going to do is make sure the positive's at the bottom and put the battery underneath, and then we've got to pin this elastic band down with the little wire hoops that we've made. Right, so that's our two batteries in and clipped together. I think what I'll do is just put some little crocodile clips on the terminals here to connect them up. So that's it. I think we now have a completely built radio. Who knows if it's going to work or not. So when we're ready, let's go outside and give it a go. So we're outside now and I've got it all wired up. I've got the antenna and the earth onto the garden tap sorted out. I've put on a little amplifier here just so you can probably hear what's going on. So let's see what happens. So let's turn it on. Hear quite a lot of screeching at the moment. Let's do a bit of tuning. Well, there's a lot of hum, as you might be able to hear, and whistling. It's definitely tuning through different frequencies. Question is, now, is that a parasitic oscillation, or is that sort of something Wi-Fi or something in the house interfering? Who knows? So I certainly can't hear any radio, but it's definitely tuning okay. Now, the trouble is there any AM left? And I'm doing it during the daytime as well, which is probably not the best thing to do. But there's clearly a signal getting through across both transistors, so that's good news. What I'll do is I'll switch over to the base of this transistor. See if there's anything there. More of the same, I think. It's definitely amplifying, but perhaps no AM signals at all to be had. You always think you suddenly hear something and then you don't. Let's just go over to the base of this transistor. No, or what about the diode? Hey, I can just hear something, but there's definitely signals that it's picking up, but I can't hear. Yeah, I think I'm hearing exactly the signals that we amplified, so can't hear anyone speaking though. Wish I had a radio ham down the road to help me out here. Send me a signal. Anyway, you might disagree with me, but I think actually the electronics is working. I'll just turn that down a little bit. I'm feeling that it's tuning okay, and we're hearing different signals when we tune it, but my feeling is there's just no AM to be had these days around here. Or if there is, it's so weak that we're not picking it up. Now, some of you might be able to tell me what's going on here. Is that actually picking up RF from somewhere, or is it the circuit oscillating? So I put my mobile phone on watching a video, and I know this is not an AM device, but can you hear the clicking? So it's definitely picking up a signal. Let me tune away from that. So it's picking up pulses, so I actually think the radio is actually working. I think it's just the fact that we're not picking up any AM signals because there might be none around here. But still, that's been a great deal of fun. I could listen on the crystal earpiece, but obviously that's not fair on you because you wouldn't be able to hear it very well, which is why I added the little valve, single valve Bravo amplifier, so it was a little bit better for the video that I'm making. Well, that's absolutely fantastic. The aircraft have gone quiet and the police sirens have stopped for once. It's, well, nearly 11 o'clock at night now, and it is working. There's a lot of static and a lot of background noise, but we can just hear an AM signal, so that's fantastic. Hasn't it been worthwhile? So we've brought this 1960s radio kit back to life again. So I do hope you enjoyed that EE08 kit electronics build and that it took you back down memory lane, perhaps all the way back to the 60s when you were playing with your kit, and I'm sure many of you have had a long and very fulfilling career since then. Anyway, as ever, do please stay to the end of the video because I cut in some extra bits that I haven't used in the main body of the film, and then right at the end I leave a few links to videos that you might be interested in. But whatever happens, I'll be making another video soon, so please do join me then.